Let's review factoring polynomials. There were 4 different kinds of polynomials that we factored in Chapter 8. One of them was the difference of squares, where we had a sum and a difference, and the middle term canceled out. We also had trinomials, where they were quadratic with a leading coefficient of 1. We had trinomials that were quadratic with a leading coefficient other than 1, and remember, those were the ones that we had to use the trick on. And then we had perfect square trinomials. Now, the one on the left and the one all the way on the right, those were our special cases. Let's take a look at the two in the center, those quadratic trinomials that we were factoring. Let's focus on the ones that had the leading coefficient of 1. Remember, with that, we were looking at what numbers multiply together to give us the last term, but then add together to give us the middle term. Those were kind of fun. Okay, let's try an example here. Here is our example. We have x squared plus 3x minus 54. Now, the first thing you'd want to do when you're given a polynomial like this is you always want to check the first and the last terms just to see if it's a special case. Are the first and the last terms perfect squares? The answer is no in this case. So I'm going to have to factor it like I would, a normal quadratic polynomial. So let's erase that here. Okay, so I am going to get ready to factor. I know that the only way to get x squared is x times x. But now I have to think, what factors do I know that are factors of 54 that multiply together to give you 54, but then also add together to give you positive 3? So if you think about numbers that multiply together to give you 54, 6 and 9 do. And could you use a 6 and a 9 to add together and get you 3? Absolutely. So we're just going to put the numbers 6 and 9 as our last terms in those two binomials, and it doesn't matter which order you put them in. Now, in order to get that positive 3 when you add them, the 9 would have to be positive and the 6 would have to be negative, right? Because negative 6 plus 9 is positive 3. Also, negative 6 times positive 9 is negative 54. So there I have factored. And then, of course, you could always just check your factoring with FOIL. You could FOIL it and just be sure that you were right. Okay, now let's try the quadratic polynomials where the leading coefficient was something other than 1. This is where you needed to use the trick. So let's do an example here. Okay, here's our example. Now again, the first thing you want to check when you're given a polynomial like this is the first and the last terms. Is it a special case? Are the first and the last terms perfect squares? And the answer here is no. So here I can see, all right, I'm going to factor it, and I'm going to end up having to use the trick because the leading coefficient right here is a 4. Okay, so let's get ready to use that trick. Do you remember how to do that? Remember, you want to take the first and the last terms and multiply them together and just kind of put that over on the side. That's 28. Now we want to think of factors of 28, numbers that multiply together to give us 28, but add together to give us the negative 16. And you can probably recall that 2 times 14 gives you 28, and you can use a 2 and a 14 to get you 16. So we're going to use 2 and 14. So that means we're going to break up this negative 16x into the two terms that made it. And that would be negative 2x and negative 14x. So I'm going to write that down here, and then I'm going to bring it over to the side so I can show my work. So 4x squared minus 2x minus 14x, that would have made the negative 16x, and then plus 7. So here are the 4 terms that created that polynomial. Okay, giving myself a little bit more workspace, I'm just going to erase my work that I've done so far here. And I'm going to pull this right over here. So I have 4x squared minus 2x minus 14x plus 7. Okay, now we're going to underline the first 2 terms and underline the last 2 terms. And remember here, I want to pull out the GCF. I want to undistribute, get that GCF. So greatest common factor of the first 2 terms would be 2x. So then let's undistribute. 2x times 2x would give us the 4x squared. 2x times negative 1 would give us the negative 2x. Okay, then remember, whatever sign this is, positive or negative, whatever it is, we're going to pull it down. Now, what's the greatest common factor of 14x and 7? Well, that would be 7. Okay, so we're going to undistribute. So negative 7 times 2x would give us the negative 14x, and negative 7 times negative 1 would give us the positive 7. Now, do you remember how what's in the parentheses here should be exactly the same if you did this right? And that's one of the factors. And then the other factor is what's on the outside of the parentheses. And in this case, it would be 2x minus 7. And now these are the two factors. So I'm going to go back over here into the green box, and I'm going to write down those two factors, 2x minus 7 and 2x minus 1. And remember that the way that you can check that to be sure that you did all of your work correctly is you could FOIL it. So you could multiply those two binomials that we just got and just double check that you get the polynomial that you started with, okay? So now let's go to our special case with difference of squares. And this is where you had the middle terms canceling out because remember it came from a sum and a difference. So let's try an example of that. Okay, so we have 9x squared minus 64. So notice how the x term in the middle, it ended up canceling out. So looking at the polynomial we have, look at the first and the last terms. What makes it a special case is that the first and the last terms are perfect squares, and that's going to help us to factor. So let's get ready to factor here. The first term, the square root of 9x squared is 3x, because 3x times 3x is 9x squared. Then the 64. Now the square root of 64 is 8. That's going to give us the last term in both of the binomials. Now in order for that middle term to cancel out, they needed to be a sum and a difference. So one of them is a plus and one of them is a minus. And that's how that middle term is going to cancel out. Now, how do you check to be sure your work is right? FOIL. Multiply and see that you get the polynomial that you started with. That's always how you check this, just to be sure that you did it right. Okay, so that was our difference of squares, which came from two binomials, one a sum, one a difference. They're exactly the same, right? 3x plus 8 and 3x minus 8. The only difference is one is plus and one is minus. Then we had the last, or the other special case, and that was the perfect square trinomial. So let's take a look at an example. Here it is. All right, so now here the trick here is to look for a perfect square in the first and the last terms. Now remember how I did that. I did that with this example, and I did it with this example. The first thing I did was I took a look, does the first and the last terms, are they perfect squares? And they were not. So I knew I just had to factor them using what I learned. But over here, the first and the last terms are perfect squares, which means it's a special case. It's a perfect square trinomial. So when I factor it, that's going to become really helpful. So the square root of the first term is x, and then the square root of the last term, 49, is 7. Now, I know that the first, like the 7 and the 7, have to multiply together to give me positive 49. So they either have to be both be negative or both be positive. But remember how they have to add to the middle term. And in order to add to be positive 14, they both would have to be positive. Okay, so this one actually comes from the square of a binomial, because this is really the same thing as x plus 7 squared, isn't it? Do you remember that one? Yes. So of course, I can always check my answer by foiling. I can multiply the x plus 7 times the x plus 7 and double check that I have that right. Okay, so these are the 4 different kinds of polynomials that we factored during this chapter. We had the two trinomials in the middle, difference of squares, and perfect square trinomial. So this is a really nice concept map to kind of keep a hold of, to look back at, to help you out when you're remembering how to factor. Thanks for joining me. Have a great day.